We're going to go through a simple engineering calculation case study, and we're going to solve it in Excel. I'm in a 100-kilogram sign hung from the end of a horizontal support beam. It's hinged to a wall. The beam and sign are supported by a cable attached to the beam and above to the wall. The beam is 2.5 meters long. The cable is 3 meters. The beam and cable weigh a small amount when compared to the sign. Find the attachment position of the cable to the beam that minimizes the tension in the cable. It always helps to draw a diagram. So we've got a wall over here on the left. We have a beam. It's hinged. We have a cable here. The cable has length C, which for this particular example is 3 meters. The length of the beam here, big L, is 2.5 meters. T is the tension that's in that cable. If we have too big of a mass, as mass goes up, tension goes up, and it might even snap. Attachment position of the cable is little x. And then we have the mass of the sign, which is big M. So let's try to solve this in Excel. Excel is a nice tool to do multiple engineering calculations because you can do case studies, and it's a nice organized way. Over here on the left, I've put in labels here for our basic data. I've copied the formula for tension here. So I'm going to vary the cable attachment position from 1 meter in increments of 0.1 all the way up to 2.5 meters. So if I wanted to, I could just go 1.2, 1.3, but there's a much easier way to do this in Excel. You can just highlight 2 or more, those cells that are in constant increments. I can go to the very lower right corner where there's that plus, and then I can drag. So I'm holding down the mouse button as I'm going down, and I'm going to go all the way down to 2.5, and you can see there's that cursor there that says 2.5. So we've filled that in. Now I'm going to put in a formula for the tension as a function of the attachment position. All Excel formulas start with equal. So our tension is going to equal mass. So I can click here for mass, and I'm going to multiply by gravity times L. So I point into that cell B6 and I click, it goes into our formula, times C. Now we're dividing by, I'm going to put a parentheses here so that we maintain the order of operation, X. So X in this case is what we're varying. That's our independent variable. So I click on cell E6 times square root. And you see in Excel we have built-in functions, so square root's already in there. The square root function, like most functions, requires a parentheses. As you can see, this box comes up to kind of help you with it. And inside the parentheses we have C squared. So I point over here, C squared is caret 2 in Excel minus x squared, so that's cell E6 squared. Be sure to close the parentheses for the square root, close the parentheses for the denominator, and then I press enter. So that is the tension. We attach that cable 1 meter out from the wall. A couple formatting things here. I can click on that and I can go to decrease decimal here just to make things look a little better. Now look what happens if I try to drag this formula down. So you can drag down formulas by dragging in the lower right. You'll see something strange that happens. If you click in this cell and then I go back up to the formula and I click in there, you can see what each term is referencing because everything's lit up in colors. So I have blue, for mass, for example. Let me press enter to go down to the next line. And if I go into that formula and click in there, you'll see that because that cell is one cell lower, it takes all of those references from the previous formula and moves them all down one. If I had moved this formula over a column, it would have moved all those references over one column. This is not what we wanted to do because I wanted to maintain, for example, when x is 1.1, I wanted m to be the same as it was when x was 1. To address this problem, we use something known as absolute references. I'm going to go back up into my original formula. To make a reference absolute, I can click in that formula, click in the middle of the reference, and I'm going to press the F4 key. So the F4 key puts dollar signs before the B and before the 5, and that makes it an absolute reference. Okay, so I'm going to do this also for G. I can click in, press F4, L, press F4, C, press F4, and then I have, what else? Just the C down in the square root. I'm going to press F4. Okay, you can also manually just type in $, if you wanted to. Okay, but F4 is a good way to do this. I'm going to press enter. It didn't change anything with that, but now if I copy this formula down, you'll see that if I click in this second line, you'll see that it made those absolute references. So that M is always going to be M. Press enter, and I'm just going to take that. I can drag it down like that, or if I have a bunch of X's on the left, for example, I can just double click down here on the right. So I'm just going to double click there, and look what happened. It auto-filled that in. We can look at the tension values as a function of attachment position, and the minimum somewhere around 2.1. Attaching the cable about 2.1 meters from the wall will minimize the tension in the cable for this particular example.